2007 Physics C Mech 3. So I've got a spring, a glider, an air track, so we're not going to have friction. That's good. So this is probably something about energy. If I've got a spring here, let's see. The apparatus above is used to study conservation of mechanical energy. Yeah, spring of force. So we know K is 440. Great. Is held horizontal. A light string. Glider of mass M. Okay. The glider is pulled to stretch the spring an amount X from equilibrium. Okay. So boom, X. And before reaching the photo gate, the glider attains a maximum speed and the string becomes slack. Okay, so in other words, the spring gets back to its natural length. Awesome. The photo gate measures time t, that it takes the small block on top of the glider pass through the information. Okay, great. And that allows them to find what X is. Assuming no energy is lost, write the equation for conservation of mechanical energy. All right. A, energy initial is equal to energy final. Work non-conservative is equal to 0. It goes from spring potential energy into translational kinetic energy. 1/2 kx squared is equal to 1/2 mv squared. And that's, yeah. Just write the equation. It doesn't say do anything with them. On the grid below, plot, okay, v squared versus x. So you can see what that's going to do in terms of this. V squared versus x. Just, I didn't look at what's next in this equation, but if I solve this for v squared over x, I'm going to get v squared over x squared is going to equal k over m, by the way. So the slope here is going to be k over m. All right, so v squared in meters squared over second squared, x squared in meters squared. It's just so annoying. So actually here on the x, I'm just going to go times 10 to the negative 2, so I don't have to keep writing it. So I need to go out to 2.5, so we'll do 1, 2, 3. I'm labeling as little as I have to here just to make this work. So actually I have to label the vertical here. V squared up to 5. So 5, 4, 3, 2, 1. So at point, so that's literally here, right? Because if this is 0.5, 0.1, so it's below 0.1. And this is 2, so it's literally at that line there. So next is 0.36. So halfway through here, 0.76. Okay. Next 0.81, 1.7. Next we have 1.4, 2.6, 2.3, 4.8. Okay. Great. Labels, axes, units, scale. Done. Best fit line through the data. Okay, this one I'm going to actually try and draw a nice best fit line for once. Some above, some below. There we go. Okay, good. And use best fit line to obtain the mass of the glider. Okay, we've already said that the slope equals k over m. So let's find the slope. So the slope is equal to, picking two nice points that are on the line. Okay, that's a pretty point. And I went through this data point, so there we go. So that's going to be, like yours are going to be different than mine, that's fine. 2 meters squared over second squared minus the data point, the second data point. So 0.76 meters squared over second squared. And then that's going to come down to 1 times 10 to the negative 2. And meters minus, and the data point is 0.36 times 10 to the negative 2 meters. So that is 1.24 divided by 0.64 times 10 to the negative 2. Okay, so we've got 1.24 divided by 0.64 negative 2. And that's going to equal 193.75. Okay, so that's what the slope is equal to. So now the mass is equal to the slope divided by hold on, I want the mass, right? Is k divided by the slope, excuse me. Wow, that was almost really silly, right? Yeah, and I know k is 40 newtons per meter divided by 1. Oh, by the way, what are my units here? Meters and meters. Cool. So meters per second squared. So 1.9.3.75. There it is. Okay. 1 over times 40 equals 0.21 kilograms. Great. Got it. The track is now tilted at an angle theta. When the spring is unstretched, the center of the glider is the height h above the photogate. The experiment is repeated with various values of x. Assuming no energy is lost, write a new equation that would apply. So this is going to be, if we make where the glider is going to be the UG is equal to 0 line, when it gets through the photogate, we can do energy initial is equal to energy final. And so this is going to be UG initial plus US is equal to KE translational. So this is going to be MGH plus 1/2 KX squared equals 1/2 MV squared. Okay. Will the graph of V squared versus X squared be a straight line? All right, the answer here is going to be no, because h is going to be a function of x, right? So if we look at this, I've got this, and that means that sine of theta is equal to h over x. Excuse me. So h is equal to x sine theta. So when I plot this, right, I have this other x term here, and so no, because h is a function of x as well, okay? So it's not going to be, in fact, it's going to kind of like cause it to slope a little bit downwards. It's not going to be a straight line, because you end up with this, like if you kind of think of a square root, because these are squares, this is one order less. It's like if these were x and v, this would be like a square root of x sort of term, which would give it that negative concavity that we're looking for.